Scientists have been trying to figure out how dinosaurs had sex for 150 years. The problem is simple. No dinosaur has ever been found in the act. Soft tissue does not fossilize. And the physical evidence, when you look at it, raises questions nobody in a professional context wanted to ask out loud. Start with the Stegosaurus. 2 tons of animal, 17 bony plates run the full length of the spine. 4 tail spikes, each up to 3 feet long, are grouped at the back in a structure called the thagomizer. The thagomizer is named after a 1982 Far Side cartoon in which a caveman points at the spikes and gives them the name. The museum kept it, and the joke is now the official term in scientific literature. A paleontologist named Heinrich Malleson at the Museum of Natural History in Berlin ran computer simulations on this problem using a Stegosaurus cousin called Kentrosaurus, a dinosaur with additional spikes on its lower back and hips. Malleson modelled whether Kentrosaurus could physically mate in the standard rear mounting position without the male impaling himself or the female. The answer was not easy, possibly not at all. The spikes would have required approaches the skeleton may not have supported. Nobody has solved this. It remains an open problem in the literature. Then there's the sauropod problem. Diplodocus, Brachiosaurus, Apatosaurus, up to 80 feet long and 30 tons. For 2 of them to mate, they had to align and coordinate without either one falling over. One theory involves shallow water for weight support. Another suggests the female crouched. Nobody has confirmed either. And then there's T-Rex. When Tyrannosaurus rex was formally described in 1906, the original scientific paper mused that perhaps the dinosaur's famously tiny arms served as a grasping organ in copulation. That theory never caught on. But the fact that it appeared in the original species description tells you something about how obvious the mechanical puzzle was to anyone who looked at that skeleton. The arms are about 3 feet long on an animal that weighs 8 tons. The geometry has never been fully worked out. For most of paleontology's history, these questions went mostly unasked in formal literature. They appeared occasionally in a footnote and then went back in the drawer. Scientists documented what dinosaurs ate, how they moved, how they fought. The reproduction question stayed mostly unasked. It was considered in the language of academic institutions outside the scope of rigorous inquiry for 150 years. Then someone looked at the ground in western Colorado and found something that had been sitting there since before mammals were relevant. Martin Lockley is a paleontologist at the University of Colorado, Denver, who studies trace fossils, not bones, but the marks animals left behind in rock while they were alive. Footprints, claw impressions, burrows. In 2016, Lockley's team was documenting theropod footprints in the Morrison Formation, a geological layer famous for late Jurassic dinosaur fossils, when they noticed something else in the ancient sandstone. Elongated scrape marks, parallel grooves clustered in specific areas. Some small, some 6 foot long, more than 50 of them across multiple sites. They ruled out nesting, territorial marking and food seeking. Wrong orientation, wrong distribution, wrong depth for any of those. What was left was courtship display. The behaviour is called nest scrape display. It exists in modern birds, shorebirds, gulls, raptors. A male selects a site and scrapes vigorously at the ground in front of potential mates. He's not building a nest. He's demonstrating that he could. It signals fitness. It's part of a larger behaviour called lekking, where males gather at communal display sites and females observe and choose. Lockley's paper described large theropod dinosaurs, animals comparable in size to T-Rex, gathering to perform this ritual in organised arenas in what is now Colorado. They went at the sandstone hard enough to leave 6-foot marks that survived 100 million years. In 2024, a follow-up study at Dinosaur Ridge, a site 23 kilometers west of Denver, documented 35 scrape marks. Researchers now believe it may be the largest known dinosaur mating arena ever found. You can visit it. It is open to the public. But there's one more detail from this period of research that tends to stop people. In 2011, 2 oviraptors were found buried together in the Gobi Desert. Oviraptors are theropod dinosaurs with large feathered tails and beaked faces. These two were oriented together in a way consistent with a mating pair and were eventually nicknamed Romeo and Juliet, the first confirmed dinosaur mating pair ever excavated. Oviraptors had large tail feathers. They also couldn't fly. Their bodies were too heavy and their arms too short for meaningful flight. Research confirmed that the tail muscles were highly flexible and built for display movement. The oviraptor shook its tail feathers to attract a mate. Romeo and Juliet died during or immediately after the performance, were buried together in sandstone and stayed there for 75 million years. The foreplay question had answers. What nobody had touched was the actual anatomy. For the mechanics of reproduction, you need soft tissue evidence, something from inside the animal preserved in the fossil record. That almost never happens. Then it did. The Psittacosaurus specimen at the Senckenberg Museum in Frankfurt, Germany is one of the most exceptionally preserved dinosaur fossils in existence. A small ceratopsian, a distant relative of Triceratops, roughly the size of a large dog, lived about 120 million years ago in what is now China. Skin texture is visible, pigmentation patterns are visible, soft tissue structures are visible in direct examination. In 2021, Jakob Vinther at the University of Bristol published a paper in Current Biology analysing the cloaca of this specimen. The cloaca is the single posterior opening used by birds, reptiles and amphibians for reproduction, waste elimination and egg laying. In the Psittacosaurus fossil, the cloacal soft tissue was preserved well enough to examine structurally. Vinther found that the Psittacosaurus cloaca does not resemble a bird's. It resembles a crocodile's. This is the key distinction. Birds reproduce via a cloacal kiss. Two birds press their cloacae together briefly. Sperm transfers. The whole process takes seconds, no penis involved. Crocodilians are different. Male crocodiles have a permanent penis stored internally that extends during mating. The process is slower and more anatomically deliberate. If the Psittacosaurus cloaca matches the crocodilian pattern, and Vinther's paper argues it does, then at least some non-avian dinosaurs had penises. Not mammalian anatomy. Something internal and crocodilian, extending only when needed. The specific structure remains unknown. The external opening is documented. The rest is inference. Birds descended from theropod dinosaurs, and somewhere in that lineage the crocodilian-style anatomy shifted toward the avian cloacal kiss. Paleontologists believe this happened relatively late in theropod evolution, which means most non-avian dinosaurs across most of their 165 million year run probably had the crocodilian arrangement. If this channel has been useful, subscribe. These are the questions natural history museums leave off the placard, and there are more of them than you'd expect. The position itself, the actual physical mechanics of how two large dinosaurs manage contact, remained unconfirmed. In 1989, a British paleontologist named Beverly Halstead decided to put it in writing anyway. Halstead described the position in clinical detail. Mounting from the rear, the male placed his forelimbs on the female's shoulders, lifted one hind leg across her back and twisted his tail beneath hers to bring the relevant anatomy into contact. He published it, stood behind it in the literature. The anatomical challenges were real. For large theropods, the tail was a rigid counterbalance for bipedal locomotion, horizontal, structural, not built for significant twisting. Whether it could rotate far enough to allow the Halstead position is an open question. The skeletal evidence doesn't resolve. For sauropods, two animals each potentially weighing 20 tons, the geometry is worse. The shallow water theory helps somewhat, it doesn't solve it. The position remained published and unconfirmed for 36 years. Then in 2025, Filippo Bertozzo at the Natural History Museum of Maastricht published a paper in Eye Science that changed the picture. Bertozzo had first noticed the pattern in 2019 while studying an Oloroteton, a large duck-billed dinosaur at a paleontology museum in Blagoveshchensk, Russia. Several tail vertebrae had healed fractures, specific compression injuries concentrated at the base of the tail in a specific location. When he recognized what he was looking at, he said, in his own words, "I had a cry of joy." The fracture pattern matched what is documented in large modern animals that reproduce via rear mounting, Cattle, sea lions, rhinoceroses. The type of injury, the location, the distribution. When Bertozzo's team analysed which hadrosaur specimens showed this pattern, the distribution was not random. The fractures appeared consistently in specimens identified as female through bone histology and pelvic measurements, precisely where stress would accumulate if a heavy male was mounting from behind with sustained force. The male dinosaur was apparently breaking the female's spine in a way that healed, repeatedly. It lines up with what Halstead described in 1989, before any injury data existed to support it. The paper also identified something beyond the mating mechanics. This fracture pattern may be the first reliable method for sexing hadrosaurs in the fossil record, not bone shape, which varies, not body size, which overlaps. Mating injury pattern. Female hadrosaurs can now be identified by what was done to them. Paleontology works with what it has. Here is what the evidence supports with reasonable confidence. Some theropods performed elaborate courtship displays in communal arenas. The Morrison Formation scrape sites are real and documented. Dinosaur Ridge near Denver may be the largest known dinosaur mating arena on Earth, and you can go see it. 2 oviraptors are in a museum after dying together in the Gobi Desert 75 million years ago. At least some non-avian dinosaurs had crocodilian-style reproductive anatomy. The Psittacosaurus cloaca in Frankfurt is real. Female hadrosaurs show tail fracture patterns consistent with the Halstead position. A paleontologist cried when he realized what he was looking at. Here is what the evidence does not support. What dinosaur genitalia actually looked like internally, whether the Halstead position was physically possible for T-Rex or Stegosaurus, how Kentrosaurus solved the spike problem, how sauropods solved the geometry, whether any of this was consistent across the 165 million years dinosaurs existed. The question that would answer more than any paper can, whether the fossil record will ever produce 2 dinosaurs preserved together in the act, remains open. The conditions have not converged in 150 years of systematic excavation. But the Psittacosaurus cloaca was also considered essentially impossible until it showed up in Frankfurt. The bathtub-sized mating arena was considered too speculative to publish until someone counted 50 scrape marks in Colorado sandstone. Until that evidence exists, what we have is this. Courtship marks in a Colorado floor, 2 oviraptors in the Gobi Desert, a crocodile-style cloaca in a fossil the size of a dog, and broken female tailbones that confirm, in the most indirect way the fossil record allows, that Beverly Halstead was probably right. 150 years of the question in a drawer. This is what happens when someone finally opens it. The companion piece on the Psittacosaurus cloaca is on screen now. Same fossil, earlier finding. The question that made this one possible to ask. The next time you're in a natural history museum, look at how the skeletons are posed, running, fighting, displaying dominance. None of them are posed doing this. Check your local museum.